release exam when they give it is that it's literally the exam itself with the instructions and everything. So if you want to, just to kind of familiarize yourself with what you'll be encountering on test day, it kind of gives you the breakdown of it. It gives you the instructions for both multiple choice and free response, so you kind of know what they're going to be saying to you. And it tells them what the... So this is literally what the proctors get, that it gives instructions about how you'll be seated and everything, and what they say to you. So just, if you want to look over it just so you kind of know what's going to be coming at you on that day, you're welcome to do so. So let's go ahead and scroll. And as we talked about last time, they give you tons of space to do work. Here's even the answer sheet you'll be using. And so you'll notice it's like only 1 to 2 questions on a page. So a great use of paper. Lots of trees have sacrificed their well-being for you. So this is just that it's the second section. I think it's just so that when the proctor walks around, it's a little bit easier to make sure you're in the correct section and not going back to the wrong section. Also, too, so this is something kind of interesting about AP. So the numbering is odd in that the first chunk, I'll show you here, our numbers end at 28. And then for the next section, it starts at number, I think it's 76. Yes. So why did they do that? I don't know. It's not that you're missing questions between, that's just what they do. So don't be alarmed by that. Okay. Yes, literally on the scan phone, you'll bubble next to 76. So it sounds like you're actually doing a lot more questions than you are. You're not doing 85, 86 questions. You're only doing... We can actually go back and look at it. So this is what your answer sheet looks like. So on the first part, I believe this is our section 1 part, so you'll stop at, what was it, 20, 26, 25, 24? I already forget. And then the next part, it starts at 76. So like they start the numbers back up for you. But obviously you won't be filling in all of section 1. I don't know if it's that they have just the same Scantron for all of their tests, like maybe history has more multiple choice. That's my guess. Peter says yes, so we're going to go with that. So you will not be filling in 75 questions for part 1. But then for the next section, it does actually start at 76. So they're not like tricky and trying to make sure you actually skip to number 76. They do start at 76 first. Okay. So let's go ahead to our answers. All right. I believe it's okay after first ones. All right. So on this, if you're wanting to do some of these on your own, again, the answer key is right here with it. So we're at 1 through 7. So we've got BB. We've got B, B, and then 3 is A, 4 is E, 5 is C, 6 is D, and 7 is E. I'll leave this up here for you for a moment. Okay, so what I want you to do is go ahead and take a few minutes, look through the ones that you got wrong, see if you can figure out what mistake you made, or maybe you just didn't have time to finish it out. And then after you've gone through any remaining ones that you still aren't sure how to do, go ahead and put tally marks next to those I already wrote out 1 through 7. Yes. Sure, yeah, I can give you one. Speedy Gonzalez is amongst us. Anyone make it past 10? Okay. So again, take a few minutes, look through, see which ones you still aren't sure how to do. Put those tally marks up on the board. And then I realized that I didn't put the answers to topic 4 on Blackboard. So in a minute, I will hold that up for you so you can check those answers. I'm sorry, guys. Let me see if I can pull it up next to it. All right, and then for topic 4, here's our, let me see if I can zoom in a little bit. Here's our first chunk of answers. All right, so here's topic 4 answers through 25, and then I'll write up 26. The board is out to get me. What's that? Yes, we are 1 week away from our math exam. Okay. So again, take a few minutes to go through, check your answers for the 2012, topic 4, see if you can figure out where you went wrong. You're welcome to ask those around you as well for some guidance, and then list up the questions you have, and we will go over those. Also, I made the key for the ones you guys had questions on for topic 3, but it appears I did not scan it. So while you guys are putting up your questions, I'm going to scan this one. Save yourselves. And note that 26 stands for this team. Alright guys, so the questions you had last time on topic 3, I went through and did the work for it. I just threw that up on Blackboard if you want to go on there and look at the specific ones you had questions on. I just took the whole list of questions and the key for that, so that's on the announcements page. Okay, so 2012, it looks like we're good there. Topic 4. Okay, so we got 21, 14, 4, 26. Okay. If you would also get out your free response packet. I know, I'm just making you guys hop all over the place. There's just so much in AP Calc. So much to do. Yeah.
I don't think
I would never find you on I'm affected. That was like honestly, the ones I showed a whiteboard? Yeah. It was I'll show you. Oh my god. One tabletop. It looked like a tabletop. Yeah, you're...
Okay, so for your function analysis charts that we did last time, we did the 2017 and 2015. And then I asked you to, for 2018 part B, to take a look at that guy. Hopefully you remembered to do so. We're going to take a look at that now. Okay. So if everyone would turn to Function Analysis Charts 2018 Part B. So this is 2018 number 4, Part B. So it says explain why there must be at least one time between 2 and 10 such that the derivative equals 2. So they like to take this type of question and turn it into usually our function analysis with charts or graphs, in which they're asking you to use either intermediate value theorem or mean value theorem. They, in recent years, have really been making sure that those are on our first response questions. So I want to recap those, review those, and take a look at this one specifically. Which reminds me that last class I gave you guys this nice staple 2-page thing that says stuff you must consider. So this is something that somebody somewhere, at some point in time, they forget this. There's a lot of variations of this if you like Google search, I don't know, AP review, something like that. I think I just Google search stuff and must have been trying to find the original document, and there are just so many variations of it. So it's really just kind of a, I don't know, a nicely organized set of information of the basics within our calculus, so that you can see we have our derivatives and our our integration rules. We've got Rolle's theorem, we've got L'Hopital, mean value theorem, fundamental theorem of calculus, all kinds of good stuff. So this is just kind of a good general overview of the different topics that we've learned. And then of course we've got like a nice pre-count part here. So our double angle identities and our sum of difference identities. But anyway, so the mean value theorem and the intermediate value theorem are two theorems that AP likes to ask about on our first response questions. And so if you want to refer to this as we talk about it, our intermediate value theorem, we are not necessarily dealing with our derivative. They could ask you to apply IDT to your derivative, but our intermediate value theorem is basically the theorem that says if our function is continuous on this interval a to b, then it must hit, if it's continuous on this interval, then it must hit all the values in between y. So usually what they ask is, does your function hit, does it say f of x equals 5? So basically, if your y value is in between your endpoint y values, and our function is continuous, then it's guaranteed that your function must hit that value at some point in time. So usually we throw a c in here somewhere, say f of c. And as long as our function is continuous, that c must fall within our range here. Now, it just guarantees that this happens. It doesn't tell us how many times it happens. It could happen more than once. But the requirement is that our function must be continuous. If it's continuous, then we have this holds true. Now, so that was our intermediate type. Basically, it takes on every value in between our endpoints. Our mean value here, that's our A-rock equals I. So for intermediate value theorem, you just need to have that your function is continuous. For your mean value theorem, you need to have that your function is continuous and differentiable. Because if it's not differentiable, then you can't do the IROC, you can't take the derivative. So a lot of times when they ask you to show that the derivative equals a certain value, as they are asking here, a lot of times that means that we are going to be using the AROC equals IROC. Not always, because they could be asking about your derivative function, but here we can see we have h of t is what's given to us, that information there, and they're asking us information about h prime of t. So the fact that they're asking about h prime of t, we're probably going to use the AROC equals IROC, and they're again just asking, does this obtain a certain value? So that's going to be kind of the hints to let you know to do the intermediate value theorem or mean value theorem. And so really to do this, we just need to figure out what our AROC is, and on this interval from 2 to 10. And if AROC equals 2, then we know our IROC must equal 2 as well, somewhere within there. That's what this is saying. At some point in time on our interval, our AROC must equal IROC. our IROC. And that comes back to the AROC is just, my AROC is if I were to draw my secant line into the slope. Our IROC is that there's some point in time, at least once, could be more than once, in which our derivative of the slope of the tangent line would be the same. Because we're talking about slopes here. So the slope of our secant line, which is just your endpoints, is going to be equal to the slope of our tangent line at some point in time. So that's the basics of our intermediate value theorem and mean value theorem. Remember that when you talk about these, you need to first make sure, you need to state that it meets the condition required before you can actually apply it. So let's go ahead and take a look at the grading rubric for this. So again, we're probably going to have to use IVT for this. So this was 2018. So this is part B. They assigned 2 points to this. So almost a quarter of your points here. So we have, again, we're looking at the interval. And so it asked us about the interval from 2 to 10. And so we just need to know, at any point in time within there, does my AROC equal to? So any time within here, does my AROC equal to? So when you go through and find your different slopes, we see that from 3 to 5, it does indeed equal to. So let's take a look. That's what they're talking about here. All right, so they have just the AROC right out here from 3 to 5, and they find that AROC does indeed equal to. And then again, it has to have the requirements that it's differentiable and continuous. So because it's differentiable on the interval and it is continuous on the interval, then by the mean value theorem, there must exist a value within our x values such that our derivative equals 2. So again, you have to state that it's differentiable and continuous. And they will always give you information about that to either be able to figure out on your own or they straight up tell you. So the fact that it's twice differentiable indicates that it is able to be taken the derivative twice. So h is indeed differentiable because you can take the derivative. And if it is differentiable, that automatically means continuous. So we have the concept part there. Okay, so that was 1 point for doing your AROC. And then 1 point for your conclusion using the mean value theorem. So you have to actually state the mean value theorem here. But again, you have to have the requirements differentiable and continuous on the interval. And you don't have to say specifically that interval that you checked. You could have said on the interval 2 to 10 since that's what they asked about. And then by MVT, there's a value within our x's so that our derivative equals the one that we were asked about. Our derivative doesn't equal our AROC. Sorry, our IROC doesn't equal our AROC. Okay, so again, that's a common type of thing we like to ask. I think on ours, so they asked that in 2018 on this question, and then I don't think they asked it on the other ones. Doesn't look like it. But I have seen in recent years that they throw it into some free response somewhere. They've really put an emphasis on it. Okay, do we have questions with our MVT, IVT? Okay, so let's go ahead and take a look then at our topic for today, which is function analysis graphs. So that's just your next one in your packet there. And once again, let's kind of take a look at the overview for it. And I think we're just going to do one of these today because they are pretty similar. Graphs. Okay. So in our function analysis graphs, again, the general types of questions they ask, they give you your graph of either your original function or perhaps its derivative. Here they've given us the graph of g, which is the derivative of f. So here they've given us their derivative. And they ask typical types of questions as they ask about increasing, decreasing, concave up, concave down, points of inflection, critical points, and max min. So usually part A is kind of just straight up asking you about the value. You have to do a derivative or an integral there. And then usually B through C, sometimes D, they ask about those other justifications and things. So this is 2018, it looks pretty standard. I felt like these ones look pretty standard. Here, once again, they gave us the derivative, and they asked us to find values. When is it increasing? Find the absolute max or min, that's a common thing they'll ask. And then they ask you some about the derivative, second derivative. Here they give us our graph of f, but notice for this one, they ask us questions about g of x. And so g of x is defined as the integral of f of x. So as soon as you see this right here, you're going to want to write g prime of x equals f of x. G double prime of x equals f prime of x. So you want to immediately apply that fundamental theorem of calculus when you see that. I believe we've done this problem before specifically. So again, they ask about relative max min, point of inflection, absolute max min, and then some amount of mean is negative. Here they gave us our derivative again, and then they asked about relative max, when is it concave down and decreasing, points of inflection, and then some about an integral. So again, you can see these are just the typical types of things that they ask. This is really where our justifications are heavily playing. So I think for this one, I wanted to look at 2018, but let me double check real quick. I think we've actually done 2017 in class before, and perhaps 2016. Take it back. I want you guys to do the 2015 one. This one here. So this is question number 5. So this is a non-calculator question. Remember, the first two are calculator, after that they're not. So it's going to be a non-calculator question. Once again, I'll put up a timer for 15 minutes. And then so you can do with that. And then once you're done, we'll go over our response. Okay, so I'm going to throw on timer 15 minutes, 2015, question 5. This. Go and show me thumbs. How did we feel on this particular response? Okay. All right, so let's go ahead and just talk through this one real quick, and then we'll look at the grading rubric for it. So again, they gave us our graph of f prime. They do tell us it's twice differentiable. That's just there to let us know that you can take the derivative of the derivative. You can do up to the second derivative. And then they're just telling us our interval there, from 3 to 4, negative 3 to 4. They're telling us we do indeed have horizontal tangents here, here, and here. And then they tell us the areas bounded by the x-axis of the graph from -2 to 1. The area is 9. So if I did the area, I mean, my curve here, -2 to 1. And then it says the area from 1 to 4. This one they said was 12. Okay. Yes, so it's telling us the area of graph of f prime. So notice they gave us just the areas. Obviously, when we integrate, we had to think in terms of positive versus negative. So they at least went ahead and told us what those area regions are. All right. So part A says find all x coordinates for which f of x has a relative maximum. So our justification for relative max, we want our derivative to go from positive to negative. Now we're talking about what our derivative is doing. So on our graph, since this is our graph of our derivative, we just want to see where our derivative or our graph goes from positive to negative. Where does that occur? -2. There's only one spot where my graph, my derivative, goes from positive to negative. Okay. B, on what open intervals contained from, so on that from -3 to 4, is the graph both concave down and decreasing. Concave down is when my second derivative is less than 0. Now, if this is my derivative graph, what is the second derivative going to be on my graph? Good. So in other words, I'm looking at where the slope of f prime is negative. And then I also want that my graph, my original function f is decreasing. My justification for that is that f prime is negative. Now, since this is our graph of f prime, we're just looking at where our graph itself is less than 0. All right. So I just went ahead and went through and labeled what slope I had. So here's a negative slope, here's a negative slope, positive slope, negative slope, positive slope. So I'm looking at where my slope is negative and the graph itself is negative or below the x-axis. So I can see that occurs here. My slope was negative, and it's below the x-axis. And here my slope is negative and it's below the x-axis. So we should have gotten from -2 to -1 and from 1 to 3. Now, normally, AP does not care whether you use brackets or parentheses, but look what the instructions said on what open intervals. So just make sure you follow that and actually do parentheses. Okay, and then C, find the x-coordinates of all points of inflection, the graph of that. Make sure, as you're reading this, that you are double checking which function they're asking about. So all points of inflection. Our points of inflection is when our second derivative changes signs. Because we're talking about f, so the second derivative, so f double prime changes signs. And again, since this is our graph of a derivative, that would be when our slope, we're looking at when our slope of our derivative changes signs. And we see that occurs here, and here, and here. Now, points of inflection are our x-coordinates. So let's find the x-coordinates of points of inflection. So make sure you are getting the x values, and that looks like at x equal to -1. Okay. X equal to -1, 1, and 3. And again, in a moment, we'll take a look at the points for this. And then D, it says, given that f of 1 equals 3, so they've given us an initial condition here, write an expression for f of x that involves an integral. Okay, so we have our derivative. What do I need to do to my derivative to get it back to my original function? Integrate. But when we integrate, we have that plus c, and we would normally integrate our function, plug in our value for c, and then, or plug in our initial condition, then solve for c and do it that way. But we don't have a function. So what we have to go back to is what we have from our fundamental theorem of calculus. Our final equals our initial plus the change. Or in other words, f of b equals our initial, so whatever that is, I'm just going to put f of 0 for now, plus our integral from 0 to whatever value we're looking at. So if I were to integrate my derivative, I get back to my original. Now let's take a look at what they gave us. They gave us our initial condition is f of 1 equals 3. So we want our original function, f of x. We have the initial condition is f of 1. So when I go to do my integral, your initial condition x value should match up like this. So my integral then should start at 1. And because we're not finding just a specific amount that wants to actually write an expression for it, our variable, we don't know what we're ending at, so our variable x is going to be a value. So then when we go to write our derivative, because we know we're integrating our derivative, we can't write f prime of x because x has already been taken, so just use t, f prime of t dt. So because they asked for an expression f of x, x is taken as the variable that we're using. So when you go to write your derivative here, you get to choose what variable. Usually t will do if x is already been claimed. So this is what we're looking at for our integral. And it said, write an expression for f of x that involves an integral. So we have our initial. Oh, we actually know our initial. Let's throw that in there. We actually know our initial. And again, our initial is based on x equal 1. So from 1 to whatever value we're looking at, we find that area, add that to our initial, that gives us our amount that we're looking for. And then you use this to find f of 4. So you just take 4, plug it in, which is why they conveniently gave us the area bounded from 1 to 4. And then f of -2, you take -2, plug it in. And once again, why they conveniently gave us our area from -2. Okay. So let's go and take a look. That's the general idea. Let's go take a look at our points distribution for that. Let's see this one a little more here. Woo! Okay. So part A, we have 1 point for identifying x equal to -2 and answer with reason. So we have it changes from positive, the derivative changes from positive to negative at x equal to -2. So it has a relative maximum at x equal to -2. So again, our justification we talked about, maximum derivative goes from positive to negative. That's the justification we've always used. Our derivative changes from positive to negative. Again, make sure you don't say it, or the function, or the graph. Call it by name. What is changing from positive to negative? F prime of x changes from positive to negative. What function has the maximum? F has the maximum. Make sure you call those by name. All right, and then our concavity and decreasing. So what we said for our concave down is when our second derivative is less than 0. And you could have said, so the slope of, you could have said the slope of f prime of x is less than 0. And then we said decreasing, that's when f prime of x is less than 0. Alright, so this one, again, 2 points. 1 point for your interval, 1 point for your reason. So we had our intervals from -2 to -1, from 1 to 3. You could have, again, written those with the parentheses. So f is concave down, decreasing on these intervals. Call it by its name, because f prime, and so what they say is f prime is decreasing and negative. So we go ahead and say f prime said f prime is decreasing. The slope of f prime is negative, or you can say f double prime is negative. And then negative is just the f prime of x is less than 0. Save yourself time, don't write out the words, write the mathematical notation. So again, 1 point for intervals, 1 point for justification. Do we have questions on our points for A or B? Okay. And then our point of inflection. 2 points for this. 1 for your points of inflection and 1 for your reason. And again, our points of inflection is because our second derivative changes signs. So point of inflection, so that's from our second derivative changing signs. Or once again, that would mean our slope of prime of x changes signs. So changes signs. All right, so identify your points of inflection. And then because f prime changes, for here they said f prime changes from decreasing to increasing, or again, f double prime changes signs, or our slope of f prime changes signs. Yes?
Why did they write x equals -1 and x equals 3, and then below x equals 1? I did say the same thing.
Why did they say that?
One's like that, but then you don't really split it up, do you?
Oh, no, because it's just asking about points of inflection. So points of inflection is just simply that it changed signs. You don't have to. So the reason why they had to split it up is because they specifically said went from decreasing to increasing, whereas the other ones went from increasing to decreasing. All you need to say is that the slope of f prime changed signs. It's because of the type of justification they use require them to split it to present the two scenarios. Okay, other questions with C? Then part D was 3 points. So they gave a point for your integrand, so a point for this setup here. So we have again our initial condition, and then from 1 to x of our derivative. And then 1 for the expression for fx. Okay, so you got 1 point. Basically how they broke it up is you got 1 point for integrating your derivative, and then you got 1 point for this whole thing here. So if you at least had integrated your derivative, then you got 1 point. If you didn't include your initial condition, you at least got your 1 point. And then you got 1 point for finding each value. F of 4 was -9, and f of -2. You had to be careful because we're going from 1 to -2. You need to negate and switch. And so we end up having value of 12. Yes?
Well, no, repeat if I said f of 1 instead of 3 for the expression.
That's a good question. I think so. I'm not positive on that because since they did give you the value, but I would think that they would be okay. My gut reaction is that they would be okay with you saying that. Okay, other questions on part D? Okay, so go ahead and total it up, see how you did, and then show me with thumbs, how did we do on this one? So it's always out of 9. Always out of 9. So it was 3 points for D, 2 points for C, 2 for B, and 2 for A. Alright, show me the thumbs. Stellar, I got an 8 or 9. Yeah, it was like a 5 to 7. It was not so great. Okay, I'm seeing a lot here and here. That's encouraging. So I feel like looking at the most recent of these types, this is the typical type. So I tried to pick the one that I thought looked most confusing, but it still didn't seem too bad. So as you can see with these ones, they are, I think the graph ones, as long as you know your justifications and you are doing a good job at naming what it is you're talking about, then usually you do fine with these. Okay. So just real quick, I want to have you flip 2 pages in your free response packet to this, the page that says Other. Okay, so next class we're doing particle motion, and then we'll also take a look at the other ones, but I kind of want to just take a look at some of them now. We're not going to actually do them, but just kind of so you see what are some other possible things they might throw at you. Because again, as we look at our different free response questions, there seem to be always these 5 categories that we're taking a day to look at each individual one, but then that 6th question is kind of a who knows what they're going to throw at you. Let's see if it'll bring it over. Okay. So our 2018 other question is about average rate of change. So they gave us a function, just original. Well, they gave us our function for f, and they asked you just about average rate of change, slope of the line tangent at a particular point, absolute minimum. So it doesn't seem too bad, really. And G is a weird thing, where they then give you a graph of G prime, and they ask you about the limit as x approaches pi over 2 of f of x over G of x. I believe for this one you ended up having to use L'Hopital's rule for that. So kind of interesting that they threw that on first ones. So doesn't seem too bad. Some kind of random topics with the average rate of change. Absolute min's a common type of thing, and tangent line's probably the average rate of change. I felt like was kind of an odd topic. All right, 2017. Here they gave us f of x, and then they gave us a chart for G and a graph for H. You know it's going to be good when they give you a function, a chart, and a graph. All right, so they asked you to find the slope of the line tangent to f. So that's not too bad, just your derivative. Then they defined k as a composition of functions. What do we have to do with this for our derivative? Chain rule. And then here, they defined m as a product, so we have to do product rule with chain rule. And then the last one, they asked us, actually, once again, to use mean value theorem. So they asked us, is there a value such that the derivative equals -4? So, again, not too weird of topics in that they had the chain rule and the product rule, but they presented it differently in that we have a chart of values, a graph, and an equation. Okay. I think we're going to look at we'll save the other ones for next time. Ooh, several differential equations. Why did I put that in the other one? Oh, because it wasn't really a separable differential. Okay, anyway, well, sorry. I'm getting for myself. Okay, I know we have just a couple minutes left, so I want to go and take a look at some of our multiple choice for topic 4 here. And let's go and take a look at 21 first. What's that? Yeah, so homework tonight is topic 5 of the multiple choice. We'll go over that next time. And our last free response topic. 21. All right, so 21 was the average value. So our average value formula is 1 over b minus a, so 2 minus 0, times the interval for a, b, so 2, of our function. So x squared square root of x cubed plus 1 dx. So average value 1 over b minus a times the interval of our function. We do have to do a u sub. Let u equal x cubed plus 1. du is 3x squared dx. I have x squared dx, and 8 divided by my 3, so I have 1/3 du equals x squared dx. I do have to change my bounds. U of 2 cubed plus 1 is 9, and u of 0, 0q plus 1 is 1. So I have 1/2. Alright, so I've got my new bounds would be 1 to 9. X squared dx was 1/3 u, so I have the 1/3 in front to u. And then this is just square root of u. So we have 1/6. Let's see, so this is u to the 1/2. So I want to add 1 to my exponent, so it'd be 3/2 multiplied by the, or divide by my new exponent. So divide by 3/2, so multiply by 2/3. U to the 3/2, evaluated from 1 to 9. And then you just plug and chug from there and you end up with this guy. So you had to set it up and then you had to do a use of it. Okay, do we have questions of 21? And then number 14 is actually easy. So I want to sneak a peek at that real quick before the questions. This is just bringing up into integral of f of x dx plus the integral of 5 dx. What's the antiderivative of 5? 5x evaluated from a to b. Over here, they already gave us this was a plus 2b. So now we just evaluate here, so I have my a plus 2b, and then I do 5b minus 5a. And then just combine from there, so we get it, is that negative 4a plus 7b. So it's just break it up and do your antiderivative is 5x. Evaluate from a to b, take b, plug it in, minus a, plug it in. And that's what gave us this. You can also use that property we have of integrals where this is just our rectangle of height 5 and width b minus a. So you can involve it's under property 5 times b minus a. That's it. You can that. Or just your antiderivative. Okay, questions on this too? So again, your homework tonight is topic number 5, multiple choice. The next class is our last class before our final exam, our final exam. You don't have to want. I'll be here. And guys, it's senior 7 and 8 today, actually.